Alright, let's get started with making this script for the car so that we can start getting it to move. So if we go to the top level car object and add a new script, so right down the bottom of the list, click on new script, and we'll call this car script. And if you double click on the car script, it will open up. Now what we're going to do is we're actually going to access the wheel collider components, and we're going to access the some of the functions and variables that wheel collider script holds. Now if you don't know already, if you click on any one of the components on the left, you'll see a little book, and if you click on that book you'll be able to get help within documentation for that particular component. So if we use that technique, we can quickly click on one of the wheel colliders. Oops. And we look at the wheel collider component, go across to the little book, and if you click on that, the internet will open up and it will go to the wheel collider. This will explain a little bit about it, and you can read through that if you want. You can also switch to scripting, where you can look at some of the properties and the methods that you can use within it. One of the most common ones is setting the motor torque so that the thing can actually move, or actually steering it as well. So setting the steer angle, and we're going to just work through those two real quickly. So I'm going to bring my code window over here and we'll get started with it. So the main thing with this car script is that we need access to the wheel colliders, and we're going to keep them separate. So we're going to make them public so they're visible in the inspector, and then say wheel collider, and we're going to call this left front, and we'll do the same for all of them. So copy that and paste. There we go. So we've got a left front, we've got a right front, we've got a left rear, and we've got the right rear. Now when we've saved this, we're going to actually access each one of these. So I've saved the code. I'm just going to jump back into Unity, and the car should have the script attached to it, and you'll see that these slots have now appeared. So we just need to drag the correct ones into the right place so that we have access to the wheel collider component and all of the methods and properties within it. So I've got them hopefully in the right place. You'll know about it if you don't. And then we're going to go back and start writing some code. So we're going to start with the most basic thing that we can do. I'll leave the start function there for now, and I'm going to change this to fixed update. The fixed update is used by the physics engine, so it's initialized by the physics engine so that it doesn't happen as fast as the computer can run. It happens at a fixed state, so it's usually 20 times a second or something like that. So we're going to start writing some code within here. So I'm going to just create, first of all, I've got a floating point variable, and I'm just going to call it y input, and I'm going to make that equal to input.getAxis. I'm going to use vertical. So this is going to be basically my throttle. You need to make sure that you spell vertical correctly. This is not great practice to have a string because it's too easy to spell it wrong, but I think I've got it right here. And then what we're going to do is we're just going to drive both the rear wheels by this amount multiplied by some value. So if we just say left rear, and then we set the motor torque equal to the y input, and we'll multiply that by let's try 2000 for now. Now this is just starting off the code real simple. We really need to tidy this up because we really don't want this value being here. We should probably make it a public variable, and we could even give it a range so that we can set it between certain values by the user. So for now we'll just leave it as it is, just to make sure that it's working, and once it is working then we can refine it a little bit. So what I'm going to do is set the Y input times 2000 for both the left rear and the right rear motors, and because I like to test things as we go, if we click on make sure it's saved, I use Control S, and then we just, when it compiles, we run it. What we should be able to do is we should be able to push forward and you'll see the car move. One little thing that will help, if you click on the game tab here and you need to see the wheels, if you click gizmos to enable them, you'll actually see the little green wheel colliders. We're going to write some code soon to put some wheels in here and move them around, but with the gizmos on you'll be able to see what's happening. So once again, if you see that when I press forward, you'll see that the back wheels actually turn and slide a little bit and then push the car forward. The last thing, or the next thing, is going to be the Z input. So I'll put them up in the same place, sorry, the X input, and we'll put this up in the same place, and we'll get the input from the get axis, and we'll use horizontal this time, horizontal, and we'll do exactly what we did before, but with the front wheels we're going to set the steer angle to the X input, and we'll multiply that by some random value. So I'm going to say 45, which is degrees, which will be either positive 45 or minus 45, and we're going to do the same with the right front, set those steer angle equal to the X input times 45, and what we'll have there is the chance the value that returns from the horizontal get axis will be between minus 1 and 1, so it should be either plus 45 or minus 45. So that is saved. Jump quickly back to Unity, make sure it compiles, and when we run this, what you should see is the right and left should make the steering turn and the forward makes it go. So you've actually got what is effectively a controllable car right now. Now it does slip a little bit and we can change some of those things, but what we want to be able to do is get some sort of wheels going for now. So that will be the next thing to do. So make sure everything's saved and we'll move on to doing the wheels. So it's not as difficult as it seems. The way we're going to do it, there's lots of different ways of doing this. We can just basically make any kind of object, and we can attach it as a child of this object, and then we can find it inside of the script. So I'm just going to do it that way. So if I click on left front and I right click on that and I create a 3D object, and I know it sounds really silly, but I'm going to add a cube. I'm going to make sure that that cube is right at the very center of left front. So if I can go back to scene view and double click on left front, you'll see as I orbit around, it's right in the very middle. Now this cube does not need a collider, because otherwise we'll get weird things, and most of the time the wheel colliders or the wheel meshes don't have colliders anyway. It's the wheel collider itself that does all the collision. So I'm just going to remove this component so that we don't have one at all. So you'll see that left front now has a cube stuck to it. We're going to do the same with this one. So I'm going to duplicate the cube, and it's the one that hasn't got the wheel collider. I'm just going to drag it onto right front and get rid of that and do duplicate again onto there and duplicate again onto there. So on each one should be a cube that is at the absolute center of the collider. So obviously we've got a problem with this because the values haven't set, so you need to make sure that position X, Y and Z is absolute center. So the left rear has got a cube attached to it. Oops. Got a cube, but its position needs to be in the center, so change that value and do the same with this one. cube and set its position to 0 and 0. Now the car's going to look pretty Gumby, but it will behave properly. Right now if you play it, nothing will happen. The cubes will just stay exactly where they are. They're not moved by the wheel colliders as they go up and down. So we're going to have to write some code for that. So if we jump back to the code here, and what we're going to need is we're going to need to write actually a new script that will control each of the wheels. So just create a new C# script. I'm going to call this wheel script, and this wheel script is going to be attached to each of the wheels. So I'm just going to drag it on so that it's in the same level as the wheel collider for each of these, for each of the 4 wheels. And what that script is going to be in charge of doing is basically just moving the mesh that's a child of it into the correct position relative to where the wheel collider is. So we'll just jump to, I'll just double click that script to open it up. So we're going to need an access to the wheel collider, so we're going to get that component in a second, so we're just going to call it WC, and we're going to need access to the mesh itself. So we'll try the transform, and we're going to call this wheel mesh. There's probably a couple of ways of doing it. We could get a child component, or we could make this public and drag it on. So probably the easiest way right now is to make this public and drag it on inside the inspector. Right here we're going to say WC equals, and we're going to get the component of wheel collider that is on this this object, and then inside of the fixed update, so it happens at the same time as the physics updates, we're going to say that the wheel meshes what we're going to do is use the wheel collider of this to get the world pose. Now this cool function, if you look it up in the help, allows us to work out where gets the physics engine to work out where the wheel collider actually is, and because this is the brand new 2018.3, we don't even need to create these variables outside of this this out function, so we don't need to create them up here like you would have done before C#7. So we can just type in exactly, more or less exactly what we see here. So we can say out vector3 pos, and what that'll do, we're going to do out quaternion, I'm going to call this rot, and what that'll do is it will fill up these variables. The WC get world pose will fill up these variables with values. I'm going to run this every fixed update, so we'll see it change as the physics affects the object. Then we're going to set the wheel mesh. That's already a transform, so we're just going to set its position to be equal to the value that we get back from the wheel collider, and we're going to set the wheel mesh rotation to the same rotation as we got back from there. So this is a little bit neater than it used to be now that it's C#7, so it looks quite neat and tidy. The last thing that we're going to do, and we might improve this because I'm not happy about the way it works, but the left front has a public wheel mesh, so we need to tell it which cube we want to use for that particular one. It has an added benefit. I'm just going to do this with all of them. It has an added benefit that you can have right side wheels and the left side wheels, because you've got an actual mesh that you're going to move based on the wheel collider. And the other thing is you can see it, so in some of the other ways of doing a car there's no wheels at all until the game starts and then it instantiates them, but this way at least we can see them. So that's more or less it. If you save all this code and you run this, you should be able to turn the wheels right and left, and you should be able to drive forward. So that's more or less everything you need to make a car. In the next part, we're going to put this on a terrain. We're going to try and deal with some of the physics. You can see how slippy these wheels are. We're going to change some of these values, and I'll explain them as we go.